Hello, you're welcome to Chemistry Hangouts. I want to believe you guys are doing fine. Very quickly today, if you're writing JUPEP, you're writing G.C.E, you're writing NECO, you're writing WAEC, any form of exam you're writing, in fact, if you're in an 100 level in any university, this video is for you. So I want you to pay maximum attention. I'm going to be explaining a whole lot of things, and I'm going to be telling you how to actually solve it. This is Chemistry Hangouts, and I welcome you guys. Very important for people that are doing G.C.E specifically, that have been chatting me, and I've told you there are a lot of videos on this channel that you can watch. We have uploaded a whole lot of content on this very particular channel, and I tell you the videos are very, very informative and educative. So I want to persuade you. I want to persuade you to watch those videos, and that's why we try updating the videos on the channel so that we can always come out with something tangible, genuine, and something wonderful. So you are welcome to today's class on Chemistry Hangout. And very quickly, please, the question I'm going to be solving, let's see the question I'm going to be solving. This is the question I'm solving. So if you're writing G.C.E, the prototype of the question you are explaining can be like this. Don't forget we have other years. Yes, we have other videos for other years that we have done. You can watch that too. Yes, you can always watch that. For people that have chatted me, there are a lot of videos, there are G.C.E videos on my channel. You can watch that. But you know, because G.C.E is an alternative to practical, if you have watched the video I uploaded the last time, I already talked about the difference between a practical that is alternative and a practical that is not alternative. Alternative practical means that you will be giving a whole lot of information, no practical done, no apparatus. Some of the things you are going to be using will be given in the question. Your own is to locate it and solve the questions that is being given. Unlike, the one that is not alternative, you have to, there are hands-on experiments. You have to get a burette, you have to get a pipette, you have to pipette and all the rest. And that makes alternative practicals to be very, very easy. I have said that on this channel, and I'll continue to say it. If you have been following my channel, you should not have problem with alternative to practical. So if you are writing G.C.E specifically, it's an alternative to practical. Okay, this video is for you. If you are writing G.C.E, for people that are chatting me for chemistry, I'm not saying this is the exact question, but we are just giving you the prototype of what to expect. So let's see this question and let's solve. So you can be given a question like this. You can be given a question like this, where they are giving you a table. Sometimes they will not give you a table. That's why I said go to my channel. There are questions for G.C.E that I gave table. There are questions on G.C.E that I did not give table. And maybe you check the comment box section. I'm going to drop the other G.C.E questions I have solved so that you can go through that one too and try to learn from it. So check the comment box section. I'm going to drop the link there. But today, this is what we are going to do. Look at this question. Your question can come like this. Yes, these are one of the prototypes that you can have, as a G.C.E student to study, because your question can come like this. So they said the table below shows the readings obtained when dilute HCl was titrated against 25.00 centimeter cube of 0.0500 mole per dm sodium carbonate solution. Right? They don't give us a table. Let's see the question. They said identify 3 errors in the readings. Can you see that they are giving you the table already? They have not done the practical because it's an alternative. They are not doing practical, so they have to give you readings, or they have to give you what we call the title value in the question. I've said that and I'm repeating that again. Check the comment box section. I'm going to drop some link there that can guide you again so that you can understand different ways by which the question can be given. So they said identify 3 errors in the readings, write the equation for the reaction, calculate the average volume of acid used, concentration of acid in mole per dm cube, mass of the acid in 250 centimeter cube of the solution, mass of the salt form when 200 centimeter cube of the base is completely neutralized. Should be completely neutralized. Should be there. Completely neutralized. Okay, so let's see. Let's look at the table. That's why you have to be familiar with all these things. Let's look at the table. Look at the table. Okay. Is there error here? Definitely there are errors there, because if there are no errors, they will not tell us to identify the errors in the readings. So let's look at, if you are familiar with the table, if you are familiar with this channel, you have been doing this for a whole lot of years now, and you should understand how the titration table looks like. So let's look at what's the error here. What's the error? Number one error that I'm seeing is that the unit of volume is omitted. You know, there is supposed to be centimeter cube here. The unit of the volume, because this is actually, these numbers are talking about volume. So we are supposed to have centimeter cube, centimeter cube, centimeter cube. I want to believe you get that. So there are supposed to be unit here. They have omitted the unit. So one of the errors. So let's go now. A Roman figure 1. Let's have the solution now. A Roman figure 1. The question can come like this. What are the errors here? The unit of the volume, which is centimeter cube, is omitted. That's one of the errors I saw. You can get your own error too. The unit of volume, because all these 24.60, you know, they are Burette readings. And don't forget, the Burette readings, they are talking about the volume, right? So if you look at the table, the unit of volume, the volume of all these measurements they have given, they didn't give it, is centimeter cube. So the unit of volume, centimeter cube, is omitted. That's number 1. That's one of the errors. Number 2 error. Let's see. You can check 2. You can check 2. What are in fact, there are a lot of errors, but you know it's already we have identified one, because there's supposed to be centimeter cube here too. Because the correct unit is in centimeter cube, which is volume, is not there. So in fact, one of the errors that I've seen is the unit of volume, centimeter cube is omitted. Let's check another one. Check the table, check the table. Let's check the table. Wow. Another thing that I'm seeing is that the readings, all of them are not in 2 decimal place. Look at this, it's 0.0. Can you see? It's 0.0, 23.5. This one is 23.50. Some of the readings are not up to 2 decimal place. This is clear, right? Yes. So this is not a 2 decimal place. This is not a 2 decimal place. So we have identified 2. Questions can come like this. That's why you have to be fortified. You can share this video. You know somebody writing an exam, share it to them. Share it to them. 3. What are other things that we can fathom from this table? Let's check. Let's check this. Okay, I'm seeing something here. Wow, there's an arithmetic error. Look at this. 24.60 minus 0.00 should not give us 24.0. Should give us 24.60. Can you see? 23.5. Okay, this one will give us this one 0. Okay, so we have for the rough. There is an arithmetic. There's an arithmetic error in the rough titration. The volume of the volume should be 24.60 centimeter. You see that now? So that's an error. You can just use the words that you like. There's an arithmetic error in the rough titration. The volume should be 24.60 instead of the what? The 24.0 that you are seeing. Have you been able to identify 3? Yes. You too, you can check. If you have any error you have seen in the table, you can always put it in the comment box section so that others too can learn. But because of our time, I think this 3 is fine. It's fine. There are obvious errors that we have there. So we have answered this. Identify 3 errors in the table. The second one now, write the equation for the reaction. The equation for the reaction, let's see. The equation is between what? HCl and sodium carbonate. Can you see that? So let's go. The equation now. The equation of reaction. So the equation of reaction is between HCl, right? Aqueous plus sodium thiazocarbonate, aqueous. Don't forget, one of the properties of an acid is that when they react with thiazocarbonate, they liberate what? Salt, water, and carbon 4 oxide. So that means here we are going to have NaCl plus H2O plus CO2, right? So let's see if the equation is balanced. Hydrogen, sodium is 2, so let's put 2 here, right? Okay, so chlorine is now 2. Let's see now. Hydrogen is what? Is 1. Hydrogen is so. Then have 2 here. So let's see if it is balanced. 2 hydrogen balance. 2 chlorine, that's balanced. 2 sodium, that's balanced. 1 carbon, right? 1 carbon, balance. 3 oxygen. Then we have how many oxygen here? 1 plus 2, 3. So if you don't know how to balance an equation, this is another example. Good. Okay, you can see. That's why I said the alternative to practical is easier. So if you are writing any exam and the exam is an alternative to practical, then you have to understand this. There is no practical, so it's much more easier. It is much more easier. So the other one, write the equation of the reaction, sorted, then the B now. From after 1. Calculate the average volume of the acid used. The average volume of the acid used. How do we calculate that? So take the first, the second, and the third, and we divide by 3. There's no need we are taking this. You know why? Because it's actually far from the first, second, third. This one is actually, they are still closer. 23.5, 23.5, 23.45. You get that now. So this one is far from them. So we can take this thing. So we say 23.50 plus 23.5 plus 23.45 divided by what? 3. So what's our answer? Let's see. 23.50 plus 23.5 plus 23.45. That's giving us 70.45. Divide by 3. Let's divide by 3 now. That's giving us 23.48. Approximately 23.48 centimeter. So let me write this. Let me write the total so that there might be mark for that, so that you don't just arrive at the answer 23.5 plus 23.45. That's 70.45. So it's 70.45 divided by 3. So that was this. You can see alternative to practical is much more easier. Can you see that? It's much more easier. So if you're writing an exam, especially GC student, that you will be writing alternative to practical, it's much more easier. There is no practical. Just understand the prototype of the question and you solve. You can get that. So, but for other exams, even if you are not writing alternative to practical, what you need, if you are doing a titration, the value you need is this. Do you see? So these are the normal questions. Either alternative to practical, either the real practical, they are going to be giving all these questions. The only difference is that you are going to get the table yourself. But alternative to practical is much more easier. So don't be afraid, don't be scared. You know, watch this video to the end, share the video to your friends, to any educational platform that you know, so that it will help them. To any educator, science educator, chemistry educator, share it to them so that they can use it to guide their students. Let's continue. So the average volume of acid used is sorted. Then I said 2, concentration of the acid in mole per dm cube. So let's check the acid that they are giving us, HCl. But if you look at the HCl here, they didn't give us any information. The table below shows the readings obtained when dilute HCl. You can see they didn't give us any value for HCl. The first formula that will come to my mind is this. Mole is equal to mass over molar mass. This is the first formula that will come to my mind. This is as a student. But look at it, we want to get our concentration of the acid in mole per dm. Do we have mass of HCl? No. We can only calculate the molar mass of HCl because they are giving us the atomic masses. But we cannot calculate, because we want to calculate mole. We can calculate the molar mass, but we don't have the mass, so we cannot use this formula. We cannot be looking for 2 unknown at the same time. So if that will not work, then this will work. This will work. CAVA over CBVB equals NA over NB. I want to believe they are still together. So what's our CA? Our CA is the concentration of acid. That's what we are looking for. Concentration of the acid, CA, right? What is our VA? Our VA is our title value, because here they even told you average volume. Can you see that? So our VA here is 23.48 over our CB. concentration of base, can you see, against 25.0 centimeter cube of, can you see, our CP, this is our base. So this is 0.05. So we have 0.0500 times our VB, that's volume of base. You can see, how do I know this is the volume? Centimeter cube for volume. So that would be 25 equals to number of moles of acid. Let's go to the equation we have written. Number of moles of acid. Acid is 2. The number of moles of acid is 2. Base is 1. You can see that's 1 mole of this. So number of moles of acid 2. Then base we have 1. I don't know if this is clear. It should be very clear. Very clear. So from there we cross multiply. Then we make Ca the subject. So we have Ca will be equal to 0.500. Sorry. 0.50500 times 25 times 2 over 23.48. Are we still together? We should be together. So let's use our calculator. 0.05 times 25 times 2. Okay? Divide 23.48. That will give us 0.106. Don't forget it has to be 2. Now 3 significant figures. So 1064. So that's 106. That will be mole per DMP. Don't forget it has to be 3 significant figures. Very, very important. 3 significant figures. Okay, that's okay. The number 3 now. They said the mass of the acid in 250 centimeter cube of the solution. What did we just get? What did we just got? We got the concentration of acid in mole per DMP. Now, you have to be very, very careful when you get questions like this. The reason is because the standard measurement is 1 DMP, which is 1000 centimeter cube. I don't know if you get that. So the meaning of this is that the 0.106 mole per DMP is telling us that you have 0.106 mole in 1 DMP. That's the meaning. Or you have 0.106 mole in 1000 centimeter cube, because 1 DMP is equivalent to 1000 centimeter cube. Now, they now ask us to get the mass. This is the mole. We want to get the mass in 250. So what do I do first? Let me first of all get the mass in 1000 first. Because this mole is in 1 DMP per DMP, meaning 1000 centimeter cube. So let me use this mole in 1 DMP and convert to mass in 1 DMP also. Then we can now move on to 250. So how do we do that? So we want to get the mass of acid, right? In what? In 1 DMP. You get that now? So how do we do that? Let's come back to this formula. Mass will be mole times molar mass. Can you see that? If I make mass the subject of formula, it's a very important formula that we need to know. So our mass will be equal to mole times molar mass. Is that not? So what is the mole? What is the mole? We have this. What is the molar mass? Let's calculate that first. Because you cannot just lift any value you have not calculated except it is given in the question. There are marks for this thing. So molar mass of HCl. They are giving us hydrogen to be 1 plus chlorine. They are giving us to be 35.5. So if you multiply it, it will give us 36.5 gram per mole. Please, calculating molar mass is in gram per mole. Note those units. Very important. So we can now come back to say our mass equals to what is our mole? 0.106 times what is now our molar mass? 36.5. Can you see that now? So our mass is now going to be 0.106 times 36.5. 0.106 times 36.5. That's giving us 3.869. I've told you to 3 significant figures. So we can just have 3.87 because it's 3.869. So we can have 3.87 gram per what? Do you see that now? So we have converted this mole to mass. You can see this mole is in DMP. So our mass is in DMP. But don't forget, what is the question? Mass of the acid in 250. Right? So I can say that 3.87 gram. We have 3.87 gram in 1,000 centimeter cube because 1,000 centimeter cube is the same as 1 dm cube. So 3.87 gram is in 1,000 centimeter cube. So in the 250 that they asked us, it will be what? Be 8. Very simple. So you take these things gradually. The reason I'm simplifying it is for you to understand, so that when you are watching the video and you want to study you already understood how we got all those values. So from there, what do we do? Our x, make this the subject of formula, this multiplied by this, divide this. So 3.87 times 250 divide 1,000. So our x will be 3.87 times 250 divide 1,000. That's giving us 0.967. Let's just say 0.968. So we have 0.968 gram. I don't know if you are getting it. So if this gram is in 1 dm cube, this is the gram we are going to have in 250. I don't know if this is clear. Check. You know, sometimes you have to go over this video over and over again. Very, very important. You have to go over this video over and over again so that you understand what you have to do. Very, very, very important. But I want to believe this is clear. And that's the reason why I said the alternative to practical is much more easier. It's much more easier. There's no practical. So understand the kind of question you are asked and you just calculate. And that's it. Okay, so how many questions are remaining? Okay, there are only 2. Okay, there are only 2 questions left. Let's quickly do that. So mass of the salt formed when 200 centimeter cube of the base. What is the base? The base is this now. That's Na2CO3. So it's a mass of the salt formed when 200 centimeter cube of the base is completely neutralized. Let me write it once so that we see it for people that want to complete the question. Okay, now let's come back to the equation. Mass of the salt formed. Let's go to the equation. This is the base, right? And that's the reason why when you react it with the acid, it's going to form salt, water, and carbon, for example. So this base formed this salt. I don't know if that is clear. So the mass of the salt formed when 200 centimeter cube of the base. Now, what is being given in the question? 200 centimeter cube of the base. What is the mole of the base they gave us? It is given already. So let's look for the amount in mole of the base. So let's look for the amount first in moles of the base. So how do we look for that? The amount, because it's going to be in mole, will now be concentration. I'm giving this formula over and over again. Why am I using this formula? They give us volume already. Do you see? 200 centimeter cube of this. They now give us what? The concentration. Because the mole in this, 25 of this will be different from the mole of 200 in this. So we already understand the molarity of the base, which is this, but they are now changing the volume. That's why questions that ask to do with them changing volume, you have to understand it. So we want to look for how many mole are we going to have when we have this concentration and we have this what? This volume. Clear, right? So that's the concentration times volume over 1,000. And I've told you, why am I always dividing by 1,000? Because the formula for amount is concentration times volume. The reason I'm dividing by 1,000 is because this very particular 200 is in centimeter cube. If it's in dm cube now, I'll just say concentration times volume. But because I know that, I've said that 1 dm cube, can you see that, is 1,000 centimeter cube. So that's why I'm dividing, because the volume is in centimeter cube. So from there, our amount is going to be, what is the concentration? Is 0.0500 times what is the volume that is given, right? 200 over 1,000. So our amount is going to be, let's have a calculator, 0.05 times 200 divide 1,000. That's giving us 0.01. Okay, that's giving us 0.01. 1. Do you remember something I said? That it has to be to 3 significant figures. Please note that there are marks for it. You know, the only one that is significant now is just like this one. So I can say 0.0100. Do you see that now? Because the zeros after this one are now significant. It has to be to 3 significant figures. Very important. That's why you can see 3 significant figures. Did you see it? 3 significant figures. So 0.001 moles. Do you see that now? Now, what do we now need to do? They did not ask us to look for mole. What did they ask us to look for? Mass. Did you see that now? So we can now say that in the equation of reaction, let's go, because what we got is this, but they didn't ask us to get this. So we are using this to get this. So let's go back to the equation. So we can say in the equation of reaction, 1 mole. Do you see that? 1 mole of Na2CO3 gave us what? 2 moles of this. Gave us 2 moles of NaCl. So what mass are we looking for? We are looking for the mass of the salt, and the salt is this. So I can say 1 mole of this is equal to this. So I can say 1 mole of Na2CO3. I want to convert this to mass now because I need the mass of this, not the mole. So I can say 2 moles into bracket Na. What is Na? 23. Atomic mass 23. 23 plus Cl 35.5, right? So that's 35.5. So it means that 1 mole of Na2CO3 is going to give me 2 into, this will be what? 58.5. I don't know if somebody is there. You know, I would have compared the mole. If what I'm looking for is the mole of the salt, but I don't need the mole of the salt. I need the mass of the salt. That's how I'm converting to this. So it will now be 1 mole of Na2CO3 is expected to give us 58.5 times 2. 58.5 times 2. You have to be careful. That's why you have to check all these things. 58.5 times 2 is giving us 117. So we give me 117 grams. So it is expected that 1 mole of this, normally, that's just a reference. 1 mole of this from the equation of reaction, from this equation, 1 mole of this, the maximum mass of salt you are expecting it to liberate is what? Is 117 grams. But how many mole are we using? Are we using 1 mole of this? No, now. How many mole are we using? Is 0.01. So 1 mole of Na2CO3 is expected to give us this. But according to the value that we got, 200, after converting this to mole, it means that we now need to get the mass of salt that this one will give us. So I can now say 1 mole of this gave me this is 0.0100 mole. Will give me what? Will give me X. Do you get that now? So our X is now going to be 0.0100 times 117. So our X will be, let's see, 117 times is 0.01. And that's giving me 1.17 grams. Do you see that now? So which means that the mass of the salt that will be liberated when we use 200 centimeter cube of the base, when they neutralize it, is going to be 117. And that's why, please go and watch some of these videos. I've told you, you have shot a lot of videos. All these things I'm doing now is under stoichiometry. There is a topic we have done on the channel, we call it mole concept. That's where we compare the relationship between mole and mass, relationship between mole and Avogadro's number, relationship between mole and molar volume. We have done that on this channel. But you know, students are very funny. When you have an exam, is when you want to visit this channel. Yes, when you have an exam, is when you want to visit this channel. So you are not familiar with all these things, and that's why you have to take time to understand this thing that I've done. Take your time to understand this. Play the video over and over and over again so that you understand this. Because when it comes to working with mole, with volume, you have to be very, very careful. I hope that is clear. Then the last question now. The last question. They said volume. Can you see that now? volume of CO2 liberated in B Roman figure 5 above, volume at STP. And what do you mean by STP? What do you mean by STP? We have done that now. As standard temperature and pressure. Okay, so the molar volume, 1 mole of any gas at STP is 22.4 dm. So what do we do? That one is easier, it's much more easier. So Roman figure 5. We know that 1 mole is equal to 22.4 dm. Yes or no? So what will be the molar volume? You can see what they did. These two questions is almost the same. What they are doing is that they are comparing mole to mass and mole to molar volume, because 1 mole is equal to 22.4 dm cube, and if I have 1 mole of sodium, is the same thing as 23 grams of sodium. Can you see that now? So the first one we did, we changed mole to mass, 23 grams. Why the last one we are doing now, we want to change mole to what? To molar volume. Do you see that now? So the question, you just have to understand. So if 1 mole is equal to this, then what do we do? If 1 mole is equal to this, and what will be liberated, because at STP CO2 is going to 22.4. So if 1 mole is equal to 22.4, then is 0.0100 will be X. Did you see that here we converted the 0.001 to mass, but here we are converting the 0.01 to molar volume. Do you see that? So this one is simpler now. So we just say S will be 22.4 times 0.0100. So that's how much. So that's 22.4 times 0.01. And that's giving us 0.224 dm. Sorted. You see that? So these are the questions. So imagine you have a question like this and you cannot solve it, that will not be too fair. And that's why I'm giving you the update on this channel. I'm going to drop some videos in the comment box section, the link to some videos, practical videos, alternative to practical video, mole concept, all those videos. I'm going to drop them in the comment box section. You can always check them, okay? You can always check them so that you revise them. So you can share this video to your friends. Don't forget, this is Chemistry Hangout. You have not subscribed to this channel, you are missing a whole lot. And that's why some people will be like, I don't know you have posted this video. The reason is because you have not subscribed and you have not turned on the notification bell. Okay? Because if you have turned on the notification bell, when we upload any video, you are going to be notified by default. So if you are still missing any of our updates, kindly subscribe to this channel and turn on the notification bell so that you would be notified when we drop any video. I love you guys. Thank you for the words of prayers. Thank you for the encouragement. Thank you for the motivation. I love you guys. Thank you so much. Those motivations has actually been keeping us going. It's not, it's stressful, but those appreciation are really helpful. So thank you so much. This is Chemistry Hangout. If you need to write the question down, you can always write the question down. Then you play the video over and over again. I still believe that you still have some few weeks to the exam, so you can always study this. Don't forget that I've dropped a physics video too on next. We are going to drop another one as time goes by. We are dropping another one on electricity and the rest, so that you'll be comfortable. I love you guys. This is Chemistry Hangout. Do have a wonderful day. Thank you.